welcome to our channel. In this session we are going to discuss about optimization of basic block. What is mean by basic block? A basic block is simply a sequence of statements. The flow of control enters at the beginning of the statement and leaves at the end of the statement without any halt. What is mean by optimization? Optimization is simply removing the unnecessary lines of the code from the program to save the memory and to improve the execution speed such that we are getting the output very fast. Okay, for doing the optimization on the basic block, we have two approaches. The first approach is structure preserving transformation. Second approach is algebraic transformation. Structure preserving transformation and algebraic transformation. First we will discuss the structure preserving transformation. So structure preserving, that means even though we are converting the unoptimized code into optimized code, but the structure of the program is maintained. Structure preserving means we are maintaining the structure of the code. For these structure preserving transformations, four techniques are there. The first one is dead code elimination. The first one is dead code elimination. What is mean by dead code? Within the program, if some particular statement is never executed, if you are running the program any number of times, if an expression or a statement never execute, that means we are never reached to that point. Such expressions are called dead code. We are eliminating such type of expressions. I will give you one example. Main x is equal to 2. If x greater than 2, printf, I am printing some message hi, else printf, print some message hello. Now observe this program clearly. Initially I assigned x value is equal to 2. If you are executed any number of times, the condition false only. Why? X value is fixed, the conditions false only, and this high printf statement never executed. Why? If this condition is always false, this statement is never executed. This is called dead code. Clear? Dead code means a statement that never executed, unreachable code. Now, how do we optimize the code? Simply eliminate such code. How to eliminate? Main x is equal to 2, printf hello. Always the if condition fail, we are moving to else block. Instead of checking the condition, directly I am printing hello. This is called optimized code, elimination of dead code. For your understanding, I will give you one simple example. For example, a within the not only main, consider some function add. A is equal to sum 2, b is equal to 3, c is equal to a plus b. Return c and printf c. What happened? First a value 2, b value 3, c is equal to a plus b, and then we are returning the value. After that we are writing printf statement. Is printf is executed? No. Once we return Any statement that we are writing after the return is not executed. Whenever the statement is executed, directly C passed to the calling function. Any statement that is written after the return is not executed. So this is unreachable code. This is called dead code. Simply elimination of dead code. Even though we are eliminating dead code, the output no problem, that is structure preserving. Second one is common subexpression elimination. Common subexpression elimination. What is the meaning? You are already calculated one expression. Suppose if the expression comes one more time, generally instead of recomputing, already the expression is calculated and the result is stored at some place. Instead of recomputing, I am already used the already existed one. Okay, that is common subexpression elimination. But remember one point, whenever you are calculated, if the expression comes one more time, meanwhile, that is in between, we are not updating the value. Clear? Consider example, you will understand clearly. A is equal to B plus C, B is equal to some A minus D, E is equal to B plus C, some F is equal to A minus D. If this is the program, first here I calculated B plus C, here I calculated A minus D. Here whenever B plus C occurred, immediately we assume that already B plus C is calculated and the result is stored in A. Now directly if I written A is equal to A, but observe carefully, here I calculated B plus C, here I am using B plus C one more time. In between, the value of B is changed. So here we are performing the operation on updated B value. So this one and this one are not same. Clear? Here B value, both are not same. This is not a common subexpression. But observe A minus D. Here A minus D calculated. Here also A minus D. From this position to this position, the value of A and D are not updated. So this is common subexpression. How to eliminate? Simply instead of recomputing, directly write the value. Already A minus D in B, directly write the value. This is common subexpression elimination. Okay. Third one is renaming temporary variables. So even though you are using this one, generally this is not required for optimization, but anyway we have to use renaming temporary variables. Suppose during execution, if I am using a temporary variable T is equal to A plus B. A plus B is the expression. The expression value is stored in a temporary variable. So the temporary instances are replaced with some new temporary instances. Internally, some logic purpose, some variable names are replaced with some other variables to simplify the process. So in such a fashion, T is replaced with X. Even though this modification does not optimize, but some unnecessary variables, some complicated variable names are removed. This is called renaming of temporary variable. And the last one is interchange of two independent adjacent statements. So even though the sentence is very big, the meaning is same. The interchange of two independent adjacent statements. Simple meaning, for example, T1 is equal to A plus B, some T2 is equal to C plus D. Suppose within the program these are the two statements. First we are executing T1 is equal to A plus B. Next you are executing T2 is equal to C plus D. For example, if first I execute T2 is equal to C plus D and next I am executing T1 is equal to A plus B, any problem? No. So interchange. These are the two adjacent statements and these two are independent. These two are independent. If these two are independent means whatever the order you are using, not a problem. Not a problem. Even though this does not optimize the code, but internally the order affects the program, remaining part of the program. Not a simple one. So for these two statements there is no problem. But if you change the order changes the entire concept. Okay. These are the four different ways for structure preserving transformation. Structure preserving transformation. Next we will move to the second one, algebraic transformation. So algebraic transformation in the sense, simply consider some set of code. The code is evaluated in terms of an algebraic equivalent. Simple thing, constant folding. First thing is constant folding. What is mean by constant folding? I have an expression x is equal to 2 into 3, y is equal to x plus k. So whenever you have an expression, calculate the expression. Simply calculate the expression. Directly we are evaluate this expression into value and then use the value constant. So expression is evaluated to a constant. Whenever that expression appear, that expression is replaced with the values, or else suppose a is equal to 22 by 7 into r into r. Here what happened? We need to evaluate the expression. So how to optimize the code? A is equal to 3.14 into r into r. 3.14 into r into r. This is constant folding. Evaluate the expression turns into a constant. Second one is copy propagation. Second one is copy propagation. Copy propagation in the sense, two forms, either variable propagation or constant propagation. Either variable propagation or constant propagation. First, variable in the sense, suppose x is equal to pi, a is equal to x into r into r. If we have an assignment statement like this, f is equal to g, copy propagation in the sense, throughout the code, instead of f, use the term g. Then automatically the importance of f is reduced, we eliminate f. Here also, how to optimize the code? A is equal to pi into r. Clear? Now there is no use of x. Automatically the value of x is removed. Automatically the value of x is removed. This is a variable propagation. Constant propagation in the sense, suppose x is equal to 3, y is equal to x plus k. Observe how to optimize. Y is equal to directly 3 plus k. Y is equal to directly you are writing 3 plus k. So the variable x is removed automatically. This is called copy propagation. And finally, strength reduction. Strength reduction means some operators has higher strength compared to another. So higher strength operators required more power and more time to execute. So higher strength operators are replaced with lower strength operator. Higher strength operators are replaced with lower strength operators. That is called strength reduction. For example, y is equal to 2 into x. How to optimize this is converted is y is equal to x plus x. So multiplication has higher strength compared to addition. That is the reason the multiplication is converted into addition. These are the algebraic transformations. So structure preserving transformation and algebraic transformations. These two techniques are used for optimization of basic blocks. Okay. Thank you.